شغال. تأكد إنه عم يدخل. Okay. Now everything is live stream. I will give you the hosting more to enable you share your screen.
Could you see my screen?
Perfect. Very clear.
Okay. If everything is okay, we could start.
One minute.
Yes, okay.
Just to activate the live stream. So. 2 minutes and the live stream will start.
Okay.
Welcome, Dr. Mr. Dental Technician Gianfranco Bartolini.
Thank you very much to invite me.
Yes. Everything is now live stream. We can start. Welcome, Gianfranco Bartolini, the design of aesthetic restoration over implants. Um, it's very interesting for everyone to get overdenture or restoration over implant with aesthetic appearance. Uh, Gianfranco is expert in the implant restoration, and he have many articles about designing the aesthetic, and he has a very nice art in designing restoration over implants. Welcome, and we are interesting to see your.
Hello, good morning, everybody. Thank you for invitation. I wanna to give a special thank you to you, Bazem, to invite me. Thank you. Let's go to start. We are ready to start. Can I go on through?
Let's go.
Okay, perfect. I'm going to have a little presentation of me. I'm a dental technician working in Italy, especially in this place called Riccione. Yes, it's a beautiful place for tourism. In this moment, we have a little bit problem, like everybody in the world, with this virus. Hopes everything gonna pass as soon as we can. Go back to what is our talk of this morning. We will talk about design aesthetic restoration of an implant, but our focus is on the single tooth restoration, and we are gonna see which solution can we adopt to simulate a good restoration. First of all, we have to clear that implant is not a natural tooth. That means that we have to consider the restoration on implants different from what is the restoration on natural tooth, because in implants are involved factors that makes our work really different. This morning, of course, I'm not gonna talk about surgery or how to choose the kind of implants, but because it's not my job, but is really correlated to what we do, because the position, the diameter, the precision, the emergence of implant are strictly correlated to our job. After all, the goal of our prosthetic restoration is the prosthesis, and we are the one who built this restoration. For this reason, we have to work very close to the surgery, to the dentist, or to the prosthesis, dental prosthesis. Okay, let's have a look to all the possibility we have to choose an abutment and crown to put on the implant. Our focus this morning will be on aesthetic restoration. We don't care this morning about full arch restoration or Toronto restoration of any kind, because it's a different way to think about that. This morning we are gonna talk of single tooth restoration on implant. We can do this kind of restoration in different ways with different system. We have the three-part restoration that include implant, abutment, and crown. And we have the possibility to have also this restoration made on implant in two parts, in which the implant support an abutment and crown in one piece. And also we can have, but is not less frequently, an implant with abutment connected in one piece, and in which we are gonna put on it a crown. How in the market there are different kind of abutment. There are the stock abutment and custom abutment, which is the main difference. In the stock abutment, we have a shape made on the medium, and we cannot change a lot. We have to work with the standard shape, with some geometry, and sometimes it's difficult to put in a right order, to create a natural anatomy. In the custom abutment, on the other side is made from a lab from dental technician, and is made on the shape and dimension and aesthetic of the designed tooth. For this is better for us to work with the custom abutment. Of course, the difference is the stock abutment have a low price, for, of course, because it's made from the factory, and in order to make less prices. In the customer abutment, that is the best choice for us, is possible to do in different material, titanium, gold, zirconia, or lithium silicate, monolithic in lithium silicate or zirconia, and even in total zirconia. The total zirconia has been discussed for some problem that we can have in a connection between the titanium implant and zirconia abutment. There are few studies that demonstrates that the connection between titanium abutment and implant is less resistant than the titanium. For this reason, in the last time, is been put in a corner, and only a few dentists put this kind of restoration. In truth, I have to say that we did a few of these, and still are in mouth and work very well. What is the best solution to be on the side of sure is the use of T-base abutment. What is the T-base abutment? The T-base abutment is a connection between implant and crown. It can be made in different material. The base is always in titanium, and up on it we can choose to do a post or a monolithic crown, or a crown, a small crown layered in micro layer. We have a lot of solution. What's important is that the connection between crown and implant is is metal to metal, titanium to titanium, and we can screw it very easily, and we can be sure that the connection will have a long life. The connection between post or crown, monolithic crown, is been done by cement. The cement is a resin cement that give us a strong connection between the two pieces. There are a lot of T-base on the market, made in different shape and with different design. let's have a look on some features that these TBs must have to be considered resistant. The first of all is the highness. It's been done a study in which is demonstrated that the average highness of a crown and abutment restoration over implant is about 8.53 millimeters, and this is really important for the bending effect and resistance of the restoration on the implant. Most of the TBs or on the market are really doesn't reach this highness and put on risk our restoration. There is also some study that has been done to use highness and diameter of the restoration on this that we can calculate. If you are interested, we will send you all this chart, because if this feature doesn't respect, we can have some failure. This is one of my crown. Trust of the mailing center, and of course after a month we have this result. Is really evident that the highness of the TBs is not enough compared to the highness of the crown. The bending effect may make this fracture. Another feature of these TBs is the soft design. Here is demonstrate that in design really sharp, we have a concentration of stress, and this can create some fracture or can create some gap between the restoration and the TB's abutment. Another thing is the cement leaking. Round and sharp shape makes possible to have a distribution and a linkage of cement during the cementation of the restoration. Another important thing is the anti-rotation spot that must assure to us an anti-rotation and stability during the cementation of the restoration when the load is put on our restoration. Another one feature can be the surface that can be sandblasted in a different way, but the mainly is this. So now let's have a look and how to choose and how to do this kind of restoration. This is a single implant on the central after an accident. The patient lose his central incisor, and the dentist put the implant. This is after a few months. The integration of implant was really good, and it took the impression and pass this impression to us. We develop the model, and first things that we do, as always in every kind of restoration, we are going to do a workshop, a design of the restoration in wax or made now designed by CAD. But what's important is, before to start, to know where we have to go and how we have the shape and the measure, because if it's necessary, we can pre-visualize the result, and if there is something to change, we can do in this moment. In this moment, we can do everything. For this workshop or digital workshop is indispensable. After this, we are going to create an abutment. In this case, we decide to do a cemented crown for 2 reasons. The first was because the screw channel was just a little bit vestibular. The second, the dentist and I decided to have much more material in the crown. This is our return. The abutment was zirconia. What is really important is the design of the contour of the abutment. We can see how horizontal going, and this is to give support to the soft tissue, and we can manage in a proper shape compared to the closed tooth. We are gonna test on the model, shape it as we prefer, screw it, and check directly in mouth. At this point, we are going to realize with the workshop the crown. In this case, we did in lithium silicate because was easy and was proved the aesthetic result of the material. Shape it and then process it with the normal press oven. Taste it in the mouth, and at this point we can start to shape the gingival contour. We can manage the emergence already in this moment. after all, we can make we can layering a ceramic. Is not the theme of this conference, but we have to pay really attention to to layering this ceramics, because this central is an aesthetic zone, and we have to care about this. Is really important. This is the final result. We can see that in this with this kind of abutment and crown, we can manage really well the shape of the tooth. Seems to be a good result, and the patient was satisfied. In this slide, we can appreciate really well the zenith managed by the crown and custom abutment in zirconia. Another way to do this, and these are close to the new tendency, and to the new way to restore tooth. We have a scan abutment that we can put in the mouth. In this case, the difference between the traditional way is that the design of abutment is made on a computer, is digital, and I'm not very fan of this technique, because I cannot manage personally, and I cannot have the good feedback that I have with the analogic workshop. But we can start always with a normal workshop, and then put on the same digital design. In this way, we do not scan this scan body, but we took an impression, and they scanned our model, but the principle is the same. We received the abutment, and we can see with this technique the design under the shoulder, and that going in contact with the tissue is really straight. Don't have any kind of design, because with the digital design is more difficult to control the emergence, because we can't read under the tissue. We tasted it in mouth. At this point, we built a ceramic crown. Even in this case, it was a lithium silicate. I'm a fan of lithium silicate. More easy for me to work. And at the end, this was the final work. What is good in this kind of technique is that we can manage, if we have material, we can manage directly in the mouth the emergence and correct with the sample the shape, just to reach the best result that we can. Of course, color and shape are really important, even without color, the shape. Another case similar, and this was the one that is not recommended in this moment, was the internal connection totally in zirconia with the shoulder. Of course, I cross the finger because it's still there. And this was our the same procedure with a scan abutment, abutment made with digital design and made from a milling center. Arrive, we are gonna modify something in the shape to reach a good gum design. Put on the lab abutment, the lab simulator. Okay, built the ceramic and put in the mouth. Even in this case, we have with this kind of abutment, we can manage and give the correct design to the crown. Okay. Now we are gonna talk about a case made with a different kind of T-base. This T-base is made to manage all the work in with lithium silicate totally. It's a special kind of abutment created to give us the possibility to make in easy time and easy passages a good result with some future respected of this. We have this abutment in that can be chosen two highness. We can see the line that represent the minimum highness that we can have. We can cut there, not more deep than this. We can have we have something that replicate this shape that we can process with lithium silicate. Or like I said, always we start from a workshop. This was an analogic workshop, and with the mask we can control in a construction our structure. In this case was a micro layering ceramics. We layered only the enamel just to give more structure and resistance to this, and it was chosen to do it totally in lithium silicate. We made the test in the mouth, then layering with all the effects, and then cemented with cement. We can see in X-ray the fitness of this crown, and it was easily to do without with the respect of all the characteristic features of this abutment. Another case was made in a monolithic, always made with this kind of T-base. It was complete in lithium silicate, works up, duplicate the works up with this special cannula, and processed with lithium silicate, stained on, and then put in the mouth, easy and faster. And now we're gonna see one of these keys made with the special, this particularly T-base abutment impression. We did realize the model, then walks up totally, put this special connection that make easy our maintenance of the feet, is calcinable. This one we can see here on the left the line that give us the stop. We cannot go under this line to be sure that the resistance of the abutment is guaranteed. Completed the works up. We can see the plastic that fit very, very well. This consider this piece processed by the press oven, and then tested in on the model and in the mouth. After this, we are layering with some effect, and what's important is that we can shape the contour of the emergence to give a natural aspect of this ceramic. Tasting in the mouth, and then we can appreciate the rounded shape that will give more life to our tissue. After this, we are gonna cement with this with the respect of the protocol recommended, and using the cement, the vitreonumeric cement. At the end, put in the mouth, and it looks like a natural tooth. The emergence looks very, very natural. Another keys that we can make with this kind of abutment, aesthetic abutment, starting from the beginning. We had in this case the 21 that has to be extracted, and we can manage this kind of restoration from the beginning with a guide, and that become temporary. In this case, like always, we start from a walks up, design the shape and the emergence. Then we transform that in a temporary, and this temporary will be stopped in a guide that will be used by the dentist as a screw guide to put the implant. The dentist put the implant in the right position with this guide, and afterwards use the same guide as a temporary, immediate temporary crown. After this, we wait for the healing, took the impression, restart with the wax up, totally wax up, screw channel, design the correct emergence, and scan it to produce the shape that we designed by wax, that we designed by the temporary. At this point, we will receive a zirconia core that we can put as a test in the mouth, reshape the contour, and start to layering. After all, we end this ceramic, put in the mouth, and we can control another time the shape, the emergence, even the aesthetic and characteristic of layering. Another good case is in choosing this kind of abutment is this. This was the initial situation, and in this case we have a bone problem because he has lost a lot of bone and gum. Start like always with the wax up, then send the wax up to the milling center, and we can appreciate in this slide that the wax up scan shows really natural shape in emergency, even if in distal papilla we have lost a lot of it. After this, create the crown and the crown abutment in zirconia, and in this way, I repeat, we can manage the emergence profile properly. That's the what we helps to create a natural aspect, a natural emergence in durability and durability of the soft tissue around this restoration. We're going to make to try make a try in the mouth, and then after layering we are gonna finish and cement directly, cement the crown and screw the abutment. Another case, I think it was the last case, initial situation, impression, develop the model, create an abutment shaped on the workshop, layering ceramic, in this case was lithium silicate, testing and shape the abutment as we prefer and as we like, and then make the final crown with all characteristic. In using this kind of abutment, it's easy. The only thing is to have the knowledge of all the system are on the market and which is suitable case by case, because we have a lot on the market of solution. The only things that we have to do is to know all characteristic and all features of these products and choose time by time for which is the best for our work. I think that was all. I want to thank you for your attention.
Thank you for very important information and very nice uh, technique you offer in this presentation. And we are interested also in the course in November, and we are looking for in advanced step-by-step procedures to do this beautiful.
I'm looking forward to show you my technique. Thank you.
Thank you very much. You can also give me the hosting backs.
Yes. Okay. Okay. I did it.
Participants, and then more on dental online conference from the list.
Okay. Okay, that was all. Bye-bye.
Okay, he left. Okay. لا أنا رجعت.
Hello. Can't hear you. Still no sound. Do you hear me? Now I can hear you. Yes.
As a connection for this sound.
Yeah.
Hi,
Right.
you can hear me now?
I can hear you. You can hear me too.
Okay.
Okay.
Okay, perfect.
Nice to meet you.
Hi, hello. Hi, Dr. Hausman. Nice to meet you.
So, when does it start?
It will start after 20 minutes. We can start 25 minutes later.
Okay. So at
So
12,
everything is, yes,
it's at 12 o'clock it starts.
yes.
Okay, good. So I've got everything prepared. Maybe you asked for foil from BrewX. Maybe I can do this or integrate this into the PowerPoint. The rest of the PowerPoint is ready. There are some pictures for sintering aids like Nasara Clean and Calibrate, and they are real videos. So the videos last around about 3 minutes each. And then I've got the foils and everything. Should be okay for 45 minutes in total.
Super, that's interesting. Everyone want to know how to correctly deal with the sintering of the zirconia
Yes.
in
Yeah.
the professional way.
Yeah, I will tell everybody because it is not our own opinion how to sinter correctly. It's the opinion of people like Tozo in Japan, the
Yes.
people who produce the powder. It's very important that everything goes in their direction. I will explain to them that we've got a company that is working with dental materials. So I'm in the dental branch of Nasera. But we've got two other branches, two industrial branches. One is automotive. The other one is automotive, aerospace, and everything you can imagine in ceramics. And so we've got a very wide area of knowledge, I think, in sintering ceramics in general. And when I came from Vita Company, so I was ordered or hired as a color specialist from Vita Company. I was the former head of training of Vita Company and the head of the test lab and head of complaints department and everything. So I had 3 different departments in Vita Company. And then I changed because I come from this area. I was grown up here in the area, close to the company, some 50, 60 kilometers in the north. So I came back from south of Germany, close to the border of Switzerland, back home in the end, and started here. Some years ago.
You are close to Düsseldorf, or
Yeah, and in a way, when you see it from your direction, yes, it's close to Düsseldorf. It's I would say it's 70 kilometers away from Düsseldorf. Düsseldorf is in the west, in direction of Netherlands, and Dortmund is in the still in the west of.
Yes, I visit every time we go to IDS. There is close to Düsseldorf that a lot of stay on this.
Germany, in the very western part of Germany. And originally I was born in Münster, which is more northern. It's a northern city from here. So how are things with the coronavirus in your area now?
Yeah, it's still everything under control, and you must to be check your temperature everywhere, everything is.
Here in Germany, it went a little bit out of control. We had everything very well under control in the beginning, but now it went a little bit out of order. So the infection rate doubled from last week to this week, so that's not good. It's lots of parties people took part in, and then they infected themselves. It's not good. But the government will take action, and then it will be stopped again, hopefully, because in winter people stay inside. In Germany, it's very cold now, and people have to stay inside, and then you have no ventilation and too many people in the rooms and everything, and that is not good. It's anyway, it's too risky. It was better in summer, everybody was outside, so that was much better.
Yeah, that's very
So you're publishing the dental lab as a magazine in your area as well?
yes, in Arabic partner for Das Dental Labor.
Yeah,
You have
yeah.
also some articles maybe we can publish in our Arabic version. It's
Yeah.
Arabic English
Yeah,
because in our area some people prefer to read in Arabic and some technicians prefer to speak English. So
Yeah.
it's B language.
Okay, that's good. Good to hear. So we are always happy to publish anything we have, because we've got many things. We're just launching a new material on Monday. So maybe you know Ivoclar Prime GT, the disc from Ivoclar Prime GT,
Yes.
and the new disc from Amann Gierbach is Generation X. And both the Generation X in particular is very good. It's a very good disc, good looking disc, but the incisor is not strong enough. It's still just 800, barely 800 megapascal. So we did something that's got 1100 megapascal in the incisor. So that is called carefree handling, and it's got the same translucency like Amann Gierbach Generation X. And the problem with the Ivoclar Prime GT is gone, because in Prime GT you have tetragonal material on the bottom, 80%, and then 20% ultra high translucent material on the incisor. And there you have a cut in the layers. You can see directly where these ultra high translucency begins. So there's no soft transition, and we made it completely different. So that's going to be completely different.
So you also produce implant from zirconia.
We produced implants in zirconia.
IZP?
We still produce implants in zirconia, but we've got something completely different. We've got a ductile zirconium, so it can be bent a little bit without breaking. It's not breaking directly. It's not that porous. So it's unique in the world. Nobody's got it, and we've got it, and it's ductile. It doesn't break directly when it's bent. So we will work on this area a little bit more, and we changed since I finally took over the product management and the project management. We changed. I did this 1 year ago, and we changed the path in the company completely, because I said we are not doing what the market wants. We need to do what the market needs and not what we think we need. It's not important what we like. It's important what the customer needs. So that was changed. It's getting better now. How is things with the how are the dentists working in your area at the moment?
The situation is medium because of the corona, but everyone, if he has not emergency treatment, maybe he postpone for better time.
Okay.
So anybody is still suspect of going in this time to dentist.
Yeah, well, hopefully they told us in the German media that they will start with the vaccine we developed here in Germany. They will start maybe at Christmas time, around about Christmas time or the end of the year. So then the first vaccinations will be given to people. It's in the third phase test, in a big test now, and maybe we can get it done. And still it needs time, because you can vaccinate in Germany maximum 60,000 people a day. So in 80 million people, you can imagine it's 1,000 days. So it's a long time. It's 4 years till everybody is vaccinated. But till you've got immunity in the whole community, maybe it takes 1.5 years. Then you've got enough vaccination for the people so that at least 60% are vaccinated. We will see. And that goes to everybody because they produce tons and tons and tons of it. The Chinese do it as well. So it's everybody needs it. It's time.
Yes, and it will be a long queue to get this vaccine. If millions of people want to be injected.
Yeah, sure.
This is
It's hard, but in Germany, it is good situation is that we produce so many vaccine doses that it's no problem to give it to all the world. So we are not like the Americans. We said, okay, give it free to everybody that the people can hear. So we depend on exports. So we need to take care that our customers are healthy as well. So it's a very good situation we have there because Germany said directly, when we make a vaccine, we make a good vaccine, a healthy one, and we need to give it to everybody because everybody is our customer. So that's a little bit a different idea than the Trump guy has, but yeah, that's it. So in which city are you?
I am originally from Aleppo, Syria.
Yeah,
I shift to
it's bitter because it's always in the news and Aleppo is always under fire.
Yes.
But,
I was starting in 2007, publishing the Arabic version, and now in 2011 I shift into Dubai and start in Dubai, continue publishing in Dubai, and we arrange many courses in Dubai for speakers from Japan, from Osaka Training Center. We also for Nondas from Greece about
I know
ceramic.
it's exceptional. It's exceptional. Yeah. It's a great guy.
I was a lecturer in Aleppo University for many years, and after I shift here and continue in Dubai, and everything is fine now. Okay.
So did you bring
Yeah.
family with you or?
Yes, of course.
Okay,
We
that's
shift
good.
all.
Good to hear. Well, we've got many Syrian people in Germany, so they came to Germany, and we are quite happy about this because all of them are well educated, good people. I knew before because I had courses with Syrian people when I was at Vita, so I knew that it's completely different. Always like the Syrians and always like the Iraqis, the Dell technician. They have been good technicians before everything was destroyed in Iraq, but the technicians was always nice to work with them. The Syrians too, very nice people and very kind and very calm. So good people. I don't know what happened in the civil war. There are nobody. We don't know what happened there. So it's horrible.
Yes.
It's really horrible.
Yes.
Well, thank God you made it. So.
Yes. We hope in very soon that everything is recovered, the history, the building, but it's difficult because a lot of people lost it in this war. That's pity.
Yeah, sure. Yeah.
Everyone.
But it will be back to, I don't know, never back to normal. It's like in Germany, okay, we started the war, we've been guilty ourselves, but it took 20, 30 years to get rid of all of this because once everything is ruined, you have to build up everything. It takes 20, 30 years to go back to normal. But it's a big chance because you can build up everything new. So you have a very new infrastructure afterwards. And if they don't make the same mistake like they do in Libya, then they will have a very stable, good environment. So we will see what the outcome might be. At the moment, it's I think the strong Russian influence is in the way, but Putin doesn't live forever. So.
Yeah. I check the time now.
Oh, it's quarter
We
to.
have still a little bit, about 10 minutes to start.
Yeah. And how are things in general? I've been to Dubai 2 or 3 times, but it's I don't know what to say. It's a huge city, huge buildings, lots of
Yes.
money. For a German, it's a little bit too hot very often because we
Yes.
Germans don't like these hot, high temperatures, but it is a fantastic city. It's
Yes.
I never lived there for a longer time. I've been always treated very kind and well, and it looked like an open society very much.
Yeah.
So
It's
it's good
a
when
fun city, like compared with Las Vegas or something like this, but
yeah, yeah.
different social.
Yeah, that is the feeling. That is the feeling when you go there. It's straight, but it's good. It feels positive. I've been to so many cities in the world, and whenever I enter a city, I can feel if it's a positive city, or if there's something that disturbs me. And I had this disturbed feeling I had 2 times in the US. Two cities in the US disturbed me deeply because I went
Yes.
to an area. Boston was very positive. New York, not so good. Everybody liked it, and I said, I don't like it. That's long ago. But
But
yeah,
also for me, I visit in 2014 United States and visit 5 times, and it's everything is big and far, and not like Europe. Europe is history, and you
it's
feel
more.
normal, normal feeling.
Yeah, everything is quite normal here. It's the only thing is the people are different because of their northern temperament. I know them because I come from this area. They are in social contact. They're a little bit to tell it funny. They're a little bit retarded. It takes a long time till they warm up and have a warmer connection to people. That is when we had Italian friends. They looked at me and said, don't you move? Don't you have temperament? I said, no, I'm not Italian. Now, calm down. I look first and then I take a time to look at everything. Then I calculate everything. And then maybe in the end, we have a very good relationship, but not from the first second. And that was disturbing to me in America because the Italians, they really like you. They go open with your arms and hug you. The Americans do it too, but they don't do it by their heart. You know, I always
Yeah.
had the feeling they don't do it by heart. And I said, no, please, I'm European. So we don't like this hugging and everything. We are not used to it. So we are not like the Japanese without any contact, but still we have our distance. It's one arm length. And I explained to them in a course in the US, and I said, oh, weird Germans. I said, yes, in a way, yes, maybe. But that is security for us. Before we tell anybody he's the greatest, and in the end we have to tell him he's not. We like to look first and then make our judgment and give the other person the possibility for a judgment too. So could be that he doesn't like us. So it's okay. Another possibility. So.
I have 5 minutes. I will prepare the connections.
Yes.
Only
Okay.
1 minute.
Yeah. Go ahead.
Welcome in the second part, the afternoon, now starting the webinar and lecture of Mr. Thomas Gaussman. We will speak about, welcome Mr. Thomas Gaussman, about the zirconia quality and sintering, how to get a perfect result from zirconia. I will give you the host so you can share your screen.
Yeah. Okay, now I've got it. Okay, go to full screen. Okay, so welcome to my lecture. I'm from the Nacera company in Germany. We are producer of zirconium discs, like many other companies in the world. But we are really pressing, firing, pre-sintering, and doing everything. We are medium-sized industrial company. The Nacera is one part, the medical part of our company, and we are the main producer of zirconium or of ceramics, technical ceramics, for a lot of automotive companies in the world, like Porsche, BMW, VW, and whatever you have. So we are one of the leading manufacturers in this. So lots of our experience in zirconia treatment comes from this area. The Nacera company was founded some 20 years ago, and they started something like a test. The former owner asked for more areas of work, and then they had the first engineer that was able to do dental zirconia. At least he had a general knowledge about this. And I joined the company 5 years ago. I'm a master dental technician, so I'm the head of technology in the Nacera company. So I'm in the development or part of the development of the discs. And I came 5 years ago from Vita company, where I was the head of training of all Vita trainings, the head of the test lab of Vita company, and the head of the complaints compartment of Vita company. But I opted to leave for my old home region here in the north of Germany, because the south of Germany is, when you have to move home, sometimes it's not that easy. People are really different. Okay, so this lecture is about Nacera. In the end, we've got, I think, at least a quarter of an hour to talk about zirconia, and you can ask me any question you like. It's a relatively new material in dental restorations. We had these hipped ones and things that were not really made for the lab. That was changed a long time ago, and still is changing. You know the general structure of zirconium. You can see here, this is the modification, the cubic modification, very translucent modification, lots of yttria inside, but not the strongest modification. Here we've got the tetragonal modification. It is not the most translucent modification, but it's relatively stable. And here it's called monolithic. It's wrong, I have to change it. It's monocline. It's like it is in nature. It's completely unsorted and unsymmetric and not really translucent. Now we come to a point that is really important in zirconia. It's the phase change of zirconia when a force is put on the material. So you've got here in the left picture a fracture coming from above into the material, and you've got all tetragonal grain in this material. It would be like a normal 3 yttria material, like we've got shaded. It's a 1200 megapascal standard material. Whenever the force hits one of these tetragonal crystals, it is changed to monoclinic. When this crystal is changed from this version here, from tetragonal to monoclinic, it will add volume to it. So it's getting bigger. You can imagine, this is only a sketch, when the force is inflicted on many of these tetragonal crystals, you will have a lot more volume added. And in the end, the beauty of the material in general, and zirconia, that is what it makes so tough and hard, is that it will compress the crack at a certain point where you've got enough tetragonal material changing to cubic material, to monoclinic material. So then the crack is compressed in the end at the tip and stopped. So the tip, the crack can't go through the material like in normal window glass or something else. So that is a good thing about this modification. Here you've got a material that is like 1,000 megapascal material. The 1,000 megapascal material is a mix between tetragonal and cubic. And you can clearly see that along this crack, you don't have that many tetragonal crystals any longer that can be changed. So the cubic can't change from cubic to monocline. So it can't compress the crack. So the crack stop function in this material, in these 1,000 megapascal or less, or like cubic's got only 600 megapascal, is always weaker. Therefore, it's much more translucent. So you always have to find a balance. But I will go later into the details of this. Here you can see the temperature and grain growth. This is very important to know. So here you can see little black spots at 1,300 degrees Celsius. These little black spots are porosities in the material. This is just a part of the material. Still here in 1,350 degrees, you still have some porosities. Porosities are never good in a material. So material must always be, material must always be very homogeneous. No blemishes, no cracks, no holes or whatever in it. So you can see here that at 1,400 degrees, this is the minimum temperature for the material to be homogeneous. So when you look at the grain is growing, it's getting bigger from here to there, from left to right. But with these lots of grain borders, you have a lot of scattering of light. So this will be very opacious. 1,400 degrees, barely strong enough, but very opacious material. Then you've got the next temperature, depending on the material you're using, because I know other people like Aman, they're using 1,450 as their general temperature of sintering. They've got a different composition in the grain, but in general, this is the table like we have. 1,450 degrees Celsius is the temperature to start. There you can start proper sintering. So our cubic material, for example, has got 1,450 degrees Celsius. 1,500 degrees Celsius here in the middle is the optimum between strength and translucency. You have wider, larger grain borders, less grain border on the same space, meaning less scattering of light, more traveling of light. On the same way, you have a good connection between the grain. Yeah, you get an atomic connection between the different grains. And this is still very strong, giving you a very, very strong material. When you go to 1,550 degrees, you can see that the grain is growing. It's getting bigger and bigger. Like I said before, when it's getting bigger, it's getting more translucent. So the point is, when it's more translucent, it's getting weaker. Like any material, when you can have one or the other, you can't have any material that gives you everything. So in zirconia, it is either you've got something translucent or you've got something very strong. So that is just fact. Then you can see, I have to go back. Then you can see that we've got here 1,600 degrees. This is the temperature of zirconzane, for example. I don't know how his composition of material is, but in general, all material is coming from, I would say, 4 or 5 sources worldwide. There are 4 or 5 powder manufacturers. One is Tozo, the other one is in, there's a second one in Japan, nearly as big as Tozo, a very good company. Then we've got a Chinese company, and then we've got some different companies. I don't know where they are, but we've got 4 to 5 producers. That said, you know that mainly every producer worldwide is using the first 3 sources. Either they buy their powder from China or they buy their powder from Japan. The Japanese powder is the best you can get in the world, so there is no quality problem with it, and they make all the science with it. So when they tell us this is the table and these are the temperatures, we believe in them. And this is what we always did. This is what we do in the industrial branches as well, because you can imagine when Porsche is ordering large numbers of some ceramic parts, they don't discuss. When something goes wrong, you get the whole bunch back, and then you get a very sharp discussion with them. So we know how to handle this. We know how to handle zirconia in general. So it's let's go to the production process. Maybe many of you know already. It's a dry uniaxial pressing in a normal press. And then the disc is pressed, powder goes to a mold and pressed from upside and the downside together. This is not homogeneous. You can see here a dark spot, you got medium colored spots here, a different size spot here, so nothing is homogeneous in the first pressing. You need a lot of pressure to make it nearly homogeneous, and still it is not perfect. So we, like many other companies, go to isostatic pressing. So isostatic pressing, the disc is put by hand into a disc, into a bag, sealed under vacuum, another bag sealed again, and then it's put into a water tank. And this water tank is put under pressure with 3000 bar. So, and this 3000 bar is giving an enormous pressure on the whole disc. So in the end, it's shrinking a little bit, which is, it's taking more raw material, but it's absolutely homogeneous. Wherever you put something into the disc, it will always be the same shrinkage factor. So I go to the next one. We've got the turning at the moment. We are just thinking about changing this. We've got the optical 3D measurement, and there's another speciality. You can build an average. This is the furnace street where we make them in. It's got a second side and a third side. So we've got, I don't know, these are, back. These are 1, 2, 3, 4, 5, 6, 7 times 3. I think we've got 21 furnaces for dental. And in each of these furnaces, you can pack up to 160 discs for one pre-sintering at round about 1000 degrees. What we do different is we unpack them from the furnace after 2 days when they cool down from 1000 degrees. And each of our discs is measured individually on this optical 3D measurement. So you don't get an average shrinking factor for everything in the furnace, because with the temperature in the furnace, it is on the bottom, the discs are colder, and on top of the furnace, they are a little bit hotter. And the ones that are hotter have a different shrinkage. So with us, it's not an average shrinkage factor, it's a shrinkage factor for each and every disc, making it very, very precise. So now I go to methods of measurements, just to make everybody understand what is important when you judge materials. Some people give you a 3-point measurement, 3-point bending test, it's called here. You have a force from above, and you have 2 points on the bottom of the disc. And then you try to bend it in this direction until it breaks. And you measure the point where it breaks. A 3-point measurement measures only a very small area. When you've got a blemish, You measure only a very small point directly under the highest force, because here is the highest force, and here you will find any blemish in the specimen and it will break. The better you polish these specimen, the higher the results will be. So this is what I call specimen tuning. This is what we don't do. We polish our specimen and either put it into a 4-point bending test, making the area of measurement much larger, or we put it into a biaxial test. Then you've got 3 small spheres here underneath and a central sphere pressing from above, having a lot of much bigger area to measure in is giving you a process measurement. So what you measure here is it can break here, here, here. You've got possibilities all over between these 2 points that you get a crack and that it will break. The better the material is produced, the more homogeneous it is, the less cracks you get here and the higher the values go here. But for sure, since you've got lots more possibilities for a crack, 3-point measurement is always around about 30% higher in value than a 4-point measurement. This is something you have to keep in mind. A 3-point measurement is the lowest possible method under norm 6872 to measure the material. So let's go over to the next one, fracture toughness. I've got many thoughts about this, and this is where people now in marketing discuss, but I'm not a marketing guy, I'm just a technician. The point is, measurement is clear, the specimen is clear, you cut into the ceramics a small gap, and then you bend it, and you will find out how good the fracture toughness under force is. In the norm for fracture toughness test, it is required that your cutting edge, here is a microscopic picture, but not from dental ceramics, has to cut at least 1 grain into 2 halves. So 1 ceramic grain must be cut into 2 halves with an edge. The point is, there is no edge on earth that can do this cut, because the ceramics grain is so fine, you have no knife, no edge, nothing at all, that you can cut half a grain of zirconium. When you can't do anything in testing according to the norm, forget about the testing results, they're not valid because they're not reproducible. So that is a big problem about this. I'm always looking at these things because I have to feed the marketing guys from a Nacera company, but I told them since many years now, we try to stay on the honest line. We try to stay honest. In the end, the technician will find out when we tell him something that's not true. No? So that is never good. So this is Vickers test. You press a pyramid of diamond into the material, and then at the end of the diamond, you get cracks in the zirconia material. And these marketing guys from other companies said, this is a brilliant idea. What we do is we measure these lengths and then we have a quality. The point is, you can't see the beginning of the crack and you can't see the end of the crack. You need a very, very, very good microscope, and this is something that nobody knows or nobody uses. They know this, but they don't use it. And you can't really see where the source of the crack is. When you can't see the source of the crack, you can't tell the line is this long, and it's not valid too. So it's another problem with the testing. I tell you another thing that's interesting. So we found out that there is something I call dental Olympics. Dental Olympics is every manufacturer is telling you that he can make it harder, that he's got a better material, that he's got a brighter material, that he's got a nicer material, and so on, so on, so on. And some people tell you, we always got the cheapest material. So it's a wild, crazy market for everybody. It's too many things to decide. And I try to at least clean up a little bit. It is not that you have to buy our discs So that is not about the lecture. About the lecture is that I clarify what's going on in the market. So here you can see that you've got a specimen thickness, 1.5 millimeter, 1 millimeter, 0.5 millimeter. You can see here you can see this is the opacity of the material. So this is Nacera Pearl 1. It's a white disc colored with normal classic liquids like we have our own, but zirconia liquid or something, then you can imagine what it is. Here you've got Nacera Pearl shaded. It's a pre-colored monochromatic disc that is A3 from top to bottom. There is no translucency added or something. There is no transition in translucency. It's just A3 dentin, that's it. So you can see here, a specimen thickness of 1.5 millimeter is giving you 86% of opacity, is giving you, for sure, 14% of translucency in A3. But then marketing comes in and tells, can't we take the raw material and measure the raw material because it looks better? So then we take the raw material without any color, which is not correct, but you can do it. So measure the raw material, you get 10% more. You get 24% translucency, looking much better. Going down, specimen thickness 1 millimeter, you get 30% already. Going down further at the specimen thickness 0.5 of a millimeter, you get fantastic 44% translucency. First of all, this is really fake because you don't need 44% translucency. When you have a material in color A3, it is never 44% translucency. So it is maximum 34% translucency in color A3, which is more than enough for the usual things in the mouth. The more, I was a former ceramist, and the more translucent you get, the more you switch to gray. If you look at some discs like the Ivoclar Prime GT, they've got a cut between tetragonal and cubic material, and when you don't paint it over, the cut between tetragonal and cubic material, you can see a line where it changes its translucency dramatically. And then in the mouth, it looks very often, it looks gray. It looks grayish. So what you need is you need less translucency in some cases. Then you've got here a cubic, which is like Katana UTML or STML. It's our cubic Pearl Nacera Q, 600 megapascal or 650 something. You can see here that in white material, it's got 31% translucency in 1.5 millimeter, but the real translucency in shade A3 in the incisor is 21%, 26%, and in 0.5, it is 41%. So very thin specimen thickness. You can see it when you mill a crown, that it needs to be very, very thin. So this is something everybody has to keep in mind. It depends all on the thickness of the specimen. And forget about this column here with the marketing things. I think this is not leading into the target. This is misleading the dental technician. And since I'm a dental technician myself, I don't like it. It is very important that you stay in normal values and that you don't compare apple and pears. You have to be realistic. And when you're a technician, you know what I'm talking about. In the mouth, it needs to be good. It doesn't need to be good in your hand or in the window or wherever. In the mouth, it decides. Okay, go to the next material and indications. You've got in the norm 68. Come on. Back. Where did I jump? Okay, here in this foil. You need minimum 500 megapascal to make, come on, to make 3-unit bridges, minimum 500 megapascal. So cubics got 600, sometimes 650, depending on the measurement. I told you before, 3-point or 4-point or biaxial press measurement. It depends. Then you've got, this is class 4 in dental materials in norm 6872. And this line here is at 800 megapascal. The minimum requirement for larger bridges is 800 megapascal according to this norm. Whoever fulfills this is in the norm and the material is okay for use. But there is something that has to be mentioned. Some people tell you they've got 1,000 megapascal material. Yes, they have 1,000 megapascal material, like for yttrium material, very often called 1,000 megapascal or 1,100 megapascal. But the point is, they measure an average through the complete disk. So on the bottom, where they've got less cubic material, for sure they've got more strength. And on top of the disk, in the incisor, where they've got much more cubic material in the mix, they've got less value. So when you look at people like Amann, they state that they've got 1,100 megapascal in generation X in an average. When you go to the details, you can see that they've got 850 megapascal in the incisor. So it is always like in a chain. The weakest part of the chain makes the decision of a chain that lasts or breaks. So this is something you have to keep in mind. It doesn't matter if they tell you our average is whatever, the average doesn't count. The weakest part in the disk counts. This is the decisive part when it cracks. So this is very, very important to keep in mind, that it's about the weakest part, nothing else. So on to the next point, about the Nocera advanced process. So since we come from the industry, the people in the industry always have the desire to produce everything always in the same way, in the same quality, in an industrial standard. So my colleague Karl Hermann, who joined the company, I don't know, 6-7 years ago or 10 years ago, he is a ceramics engineer, and he brought a lot of knowledge with him, a lot of knowledge about these process tools we have. So sometimes you've got a furnace with a molybdenum, silicium, or silicon heating. When it looks like this is no good, because this is silicon oxide that's on the surface. And this silicon oxide can lead to discoloration in the direction of yellow for the material. So it should look like this, silky, smooth, and gray. How to get this back? I tell you now. So we've got something that is called Nocera Clean, and this is a small film. I just let it run. Hopefully it works. Yeah.
Hello and welcome to Dockeram Medical Ceramics in Dortmund. My name is Alexia Gaussmann, and I will show you today the correct use of Nocera calibrate set for sintering furnaces. First, unpack all parts from the calibrate case. Take one ceramic ring from the delivered packaging. Place this ring on your sintering tray between the restorations to be sintered. Start the sintering program as used. After the sintering process is completed, remove the ceramic ring from the tray and get the measuring gauge from the set. Insert first the gray calibration body into the device. Tap slightly the base plate to align the calibration gauge. Set the gauge dial to the material-specific value given on the ceramic rings packaging. There are different types of slots available. Here, for example, we sintered 3 white TZP pearl material at 1500 degrees Celsius. With pearl, we have to calibrate to 64. With the gray body still positioned, turn the dial gauge until it indicates 64. Replace now the calibration body by the sintered ring and read the value. Each scale mark corresponding to 2 degrees Celsius, counting from 0 to the left, 2, 4, 6, 8, 10 degrees. Ideally, this value should be 0. If you observe a deviation on the left, like in this case, the temperature into the furnace chamber was too high. The sintering program will be adjusted 10 degrees lower. Let me illustrate by another example. If at the contrary, the deviation is observed on the right from the 0, like here, 11 scale marks corresponding to 22 degrees Celsius, the sintering temperature will have to be increased to 22 degrees higher. I hope this video helps you understanding and getting great and constant results. Don't hesitate to contact us for more information. Keep in touch and stay well.
Okay, so that was the first video on Calibrate. Very useful tool to calibrate your furnace. This is very important in sintering. This is one of the most important steps, and I think still we are the only ones who offer this. And we already worked on the Calibrate Mark II for the future. So one day in the future, we will bring something a little bit easier. But I think with this explanation, it's already easy to use, and it's very useful. I always tell a dealer, for example, or people with a larger lab to buy this device because first of all, it's not very expensive, but it's a very powerful tool. So after you know how much deviation you have in the furnace, you know the furnace will lose its function step by step like a car brake. But you don't have a good feeling for it because the change of color, change of translucency in the crowns goes so slow. And there you always have a chance to calibrate your furnace. Once in a while, we tell people to calibrate their furnace when it's used every day with big loads, maybe every 2 months. And when it's used frequently, not every day, maybe calibrate 3 times a year. So then you always know that the temperature in your furnace that is given in your display is the correct temperature. So it could be that the display will show you something like 1500 degree you need for sintering the material. You type it in, but the furnace doesn't give you 1500 degree because the isolation in the furnace, for example, will lose part of its function over the years. Yeah? And then the furnace has to power more and more to give it the required heat to keep the temperature up. So just go to sorry. Now I go to Nacera Clean, another video. This is the video normally I wanted to show first, but okay. This is the video about the material we have for cleaning the furnace. Like I said before, when the heating rods have these whitish material on top, these silicon oxide, you need to do something. So my advice is to clean the furnace chamber with a vacuum cleaner when it's really cold, and then take the tray and put, you can see it in the video, it's better explained, and put Nacera Clean on top of this, and then do a regeneration firing. The regeneration firing meaning, first of all, ask your furnace producer how to do it. Many of them know how to do it. Some of them have a program that exists. And otherwise, the advice is to go to the highest possible temperature of the furnace, hold it for 30 minutes, and go with the highest possible heat rate so that the heating rod will glow through. Otherwise, when it's heated slowly, it goes on, off, on, off. And this has to be avoided by going up very steep in temperature. So I'll show you the video now.
Hello and welcome to Dockeram Medical Ceramics in Dortmund. My name is Alexia Gaussmann and I will show you today the correct use of Nacera Clean LT powder. First, vacuum clean your furnace chamber and the sintering trays you are using. For a complete cleaning cycle or basic cleaning, fill your sintering tray with the right amount of powder to cover its surface. If your sintering furnace is designed for several trays, fill them all with the same amount of powder. Place them all in the furnace chamber and run your sintering program. Repeat after that the process if required. For a maintenance cleaning or to avoid your sintering furnace to be polluted, use Clean LT in each sintering process. Put a small amount of the powder on the lid and spread it to increase the reactive surface on which the impurities can settle.
The sound is not. Can we hear the sound? Okay.
Hesitate to contact us for more information.
I switched on.
Keep in touch and stay well.
Okay, calibrate we already had. This is a picture of a milling test. This is the norm test now. That was done by our engineers. So they call it a Merlon test because they are all fans of, I don't know, Lord of the Rings or something. I never read this. I've got no time. I have to play with a child instead. This is real. And the wall thickness here is 0.2 of a millimeter. So it's just to show how thin the wall thickness in our disc can be milled without breaking. That's just another test. And this is called Nacera inspection. You can see here that you've got a crack running along here and here. So what we did is we took this big bridge and then I heated it up to 1100 degree in a furnace. And then I took some cold, really cold scissors and inflicted a crack here because I needed a crack to show what this Nacera inspection does. It's a bath of liquid. You put big work into this liquid and you will detect under ultraviolet light blemishes when there's a crack or something before you go and veneer everything in painful work. You can see that there's something wrong. If everything is good, fine. But it's just another method to test your material and avoid more work. So in my eyes, it is really important to do all of these things. I will close this PowerPoint now and open another one to show BlueX, because Bassem asked me to show BlueX. Just go out of these. Just a second. Just have to look if he's got something in it. It's a guy from Italy called Germano Rossi. And no, don't want to work in this PowerPoint, just want to show. Okay, it's a very good Italian technician. Maybe in the end, if you're interested in some lectures from him, I can make a contact for you, Bassem, because he's doing all these big bridges in Italy. He's working with people in Roma and on all the universities. So he's a very, very good technician. And he worked with these materials that are all the materials we work with usually. This is what he did. He made this bridge. It's not from the new materials, it's from one older material. This is the cutback. This is BlueX. So here you can see in BlueX, BlueX is a liquid that is blue, comes in a bottle. When you paint BlueX on the incisor of a crown, the unit, the number of units is limited to maximum 4. Normally, I would say a certain span. In the old instructions, we've got 3. I made it 4 because it doesn't work in the anterior. Sometimes you've got a very small span in the lower jaw and you can't do 4 units. So it's doesn't make any sense. It is limited due to the fact that this is real yttria. This is nothing else. It is real yttria. So you are dotating the material and you're changing the internal structure. And you can see in this little picture that it goes from less translucent to much more translucent. So you're changing the material yourself from 3 yttria, normal tetragonal material, to 4 yttria material. So you don't need to change the whole disc and weaken the whole disc. You're just changing only partially the disc. And on top of this, it's not even weakening it because it's surrounded by the 3 yttria material and builds up pressure due to the change of volume. So the 4 yttria material is building up a little bit more volume, pressing against the material outside, building up more pressure. It's even stronger afterwards. So the only downside is when you apply too much of the BlueX in the wrong sizes, wrong places, like connector area or somewhere, you can get torsion in the bridge. So this is where you have to be aware and really, really careful. This is what I call an expert material. When people are really good, they can use it. They have to get used to it, but don't paint everything in BlueX because it gives you not the best result in the world. You have to get used to it. Once you're used to it, it's a beautiful material. So we worked a lot with it. So that is where he applies it now. And this is how he prepares the bridge with the colors. And this is what he's doing in his courses as well. And there you can see this translucent, grayish, translucent effect. So this is a monolithic material and then changed with BlueX, the base layer, and then he applies all the colors from Saron Ocean One Touch and modifies the whole bridge. I just go to the end, hopefully. Come on, next picture. So he's doing a lot of this work and everything for the mouth for sure. So that is what it looks like in the mouth. It is for sure a little bit layered, but only with paste ceramics. It's nothing dramatic, and that is what it looks like in the mouth. for sure Italian patient. Southern people like to have brighter teeth, but that's not special for the south. It's the same in Germany now. So multilayer A light, just go through it quickly. That's how I paints it. Mixture between the normal colors, and here you can see the translucency, how it comes in the corners everywhere. So it's augmented, it's getting better and better. And here you can see how he prepares. It looks like bone. In the end, it ends up as like gum. So he will veneer this. But you can see what he does. It's not much. And in the new materials we developed just one now. That's going to the market very, very soon. You don't even need to layer on top. This is directly as it needs to be. So this is, I really like his work because it's always impressive. Outside and inside the mouth, it's always good work. Yeah, there it is in the mouth. No, okay, escape. Okay. Just one last small video and then we can go to question and answer. This is our brand new material called Nacera Natural. And these are one of the first few tests. This is in the same category like Amann Gierbach Generation X and the Ivoclar Prime GT. So this is self-explaining, the video. This is called Nacera Natural because it's really natural looking. I've got one picture I don't know, 2 hours ago, I got a picture from Witten, from a guy who made a big work, but it's just a handy photograph, but it is good. It looks very promising, the material. He was very happy as a dental technician, and patient seems to be happy as well. The shade is very good, and you can see how it looks in the mouth. It's made in Switzerland, the work. And that was just a prototype he had. It looks better even today. We put a lot of things to it. So it's looking even better. But this is how it looks. The centrals and the laterals done in this, and they are blocked and together. So, okay. So if you've got any questions, just go ahead, whatever you have.
Thank you, Mr. Gassman, about very interesting information you shared with us. It's very beautiful, interesting information. We have the question, what's your preference, 3-point test force or 4-point to give the flexure strength in a clear or correct way?
The best is, or the most important is that you know that a 3-point measurement will give you 30% higher values. So when you compare a 3-point measurement to a 4-point measurement, you have to keep this in mind, that the 3-point measurement on the paper looks better, but you have to you have to calculate that it's 30% less. Yeah, the 4-point measurement is much more critical and giving you 30% less. So you have to add on a 4-point measurement 30% to compare both. That is very important.
One question about we can use short sintering cycle
Yes.
for your material, and what
If
is the average of
in yeah,
impact on this short average on the final
in
flexure strength?
in our material is the speed sintering cycle is like you start with 60 degree to 1000. And I would advise that you get the information from Regina to every customer you have. So we can send it out directly. We've got the curves graphic and we've got instructions for use. But I will explain it. It's a 90-minute curve, single unit only, and 90 minutes sintering. 60 degree to 1000, 40 degree to end temperature. Stay at the end temperature for half an hour. Then go down 40 degree to 1000 degree, go down to 300 degree and open the furnace. This is round about 90 minutes. And this is a very short cycle, but it's approved by the Nasera engineers. It's okay. They never had any failure. They measured in crack test and everything is fine. It's good. It works.
One question about stabilizer. How long span bridge we need then to use the stabilizer in the CAM software?
The stabilizers, what do you mean? The connectors or the stabilizer itself?
Yes, the stabilizer, the support
Okay,
in the
there's many
long span bridge
different
to
there's many different sinter supports. So it would be a topic in itself to show everybody how to sinter, how to support correctly. This is a video we will make in the future, in the relatively near future, although we've got so many things to do now. This is depending on the situation. The only thing I can tell you is the connection when you've got a large span bridge, for example, should be where you have the canines, where it goes into the curve, the large span bridge, and on the last units. So when you've got, for example, a bridge from 7 to 7, yeah, here at least in Europe we tell 7 to 7. So when you've got a bridge from 7 to 7, you have to connect at 7 and at 3 and maybe at 1 interdental. So this is 3 connectors to the support, to the sinter support. And then my advice is always to sinter it standing, and the sinter support itself inside can be either filled with crowns when you've got something in the correct color, but you have to take care that the sintered support is thinned out correctly. So it can't be too thick. It must be a little bit thinned out.
perfect. And one question about the healing of the zirconia from tetragonal to monoclinic. When this formation is happened, there is any table explain exactly how much the aging affecting or impact on the flexural strength of the zirconia material with the time.
The phase change is only a crack stop. And the table about the low temperature degradation, I don't know. I have to look it up. I've got so many dissertations on my computer. Maybe I can find something from a dentist or someone who did these tests. What we know is the more aluminum is in the mix, the more stable it is in the mouth. So you don't lose any strength in the mouth. The more aluminum is inside, this meaning the less translucent, the more stable it will be. Yeah, that's for sure. But the cubic won't change anyway. The cubic doesn't change anything. So cubic will not lose any strength in it. But in general, it is not that dramatic because you've got, we worked together with Dentaurum for a long time. And François Lelièvre, the leader of development in France, of the French branch of Dentarum, of the development people there, told me long ago, and he said, yeah, but we put glaze on our units, and normally you have no temperature degradation. It's minimum, because the glaze is in the way, it's blocking the material from putting water into it, so it is minimal. And our materials always have a wide band of strength, so there's no problem if you lose a little bit of megapascal over the years. But I will look it up. I will look it up.
Okay, very nice information. Thank you very much, Mr. Thomas Gaussman,
You're welcome.
and wish to meet you also again in near future
Yes.
in
Okay.
another lectures.
Yeah, nice to be with you, and was a pleasure.
Thank
Thanks
you
a
very
lot.
much. If you want to change the hosting for me back,
Yeah, I have to look it up. No, it works.
or if you on the participants.
Okay. I just say bye-bye.
Okay, thank
And
you
you
very
are
much.
the new host. Okay.
Thank you
Bye-bye.
very much. Have a nice day. Bye bye.
Yeah.
Okay, cool. We are waiting now for the dental photography was Mr. Chris Chmielewski, and he will show us a new tricks and techniques with the dental photography.
Mute. Do you hear me?
Yes, fine, very clear.
It's nice. Then it's nice. I am just online, so we can just prepare ourselves. I don't have, let's say, the speaker just to hear me, so I don't control it. So in case if you will see that I am losing the signal, just interrupt me or communicate me through the chat. As well with the questions, I think with the questions would be the best just to have an option that people will do it through the chat, and then I will read it, or you will give me some questions at the end of my webinar. Yeah, super. So if you are ready, we can actually start.
Okay, we are waiting 1 minute or 2 minutes. We are ready. I will transfer the hosting for your computer. Yes.
Okay. Now I am the host. Okay. So let's try. I will try to share my screen. Okay. So now the system asks me just to have access to Zoom later. Okay. What is happening now? Let us just come back to the Zoom. So, which one we should share? Desktop. Okay. Now we have the desktop. Sorry, some technical issue I have right now. I hope it is something strange. ready. So it should be. Jak myślisz? Chodź, Andrzejku, zobaczmy, bo w tej chwili nie jestem w stanie zszerować swojego screenu. To jest jako kamera, tak? I teraz tak.
To masz tę ekranę, którą wyświetla.
Muszę.
Tu na tym desktop 1, tak? To jest to, co potrzebujemy.
Ale to nam daje z tego komputera. Nie daje nam sygnału z Blackmagica, tak? Czyli tak jakbyśmy musieli mieć Blackmagica podłączonego do tamtego komputera.
Tak.
Czyli to zostaje tu, a output w tym momencie z tego, ponieważ mamy na komputerze tutaj. I need one minute, just we will continue shortly. I teraz potrzebujemy kabel z przejściem USB na HDMI, czyli odłączamy ten pozostaje. Nie, tu tego auta dajemy, tego dajemy tu, dajemy tu, tego dajemy tu. I tego dajemy tu. Czy coś pokazuje? Sorry, sure. Preferences. Czyli tamten nie ma wejścia, tak? Czyli jeżeli po USB-C, to w tym momencie mamy to, ale to mamy po USB-C, tutaj jesteśmy podłączeni już.
Czyli może ten masz wyświetlić.
No tak.
To ATEMA
Nie.
trzeba wyświetlać.
Nie, to nie jest ATEM, tutaj to nie chodzi o to, żeby tutaj ATEMa wyświetlać, nie?
Ten panel, wydaje mi się, że tam powinieneś wyświetlić ATEMA. Ja wtedy to powinien załapać jako ekran. Pytanie, czy możesz?
Nie, już jest za późno. Dzisiaj po prostu muszę przełączyć na ten komputer. Tak, nie mam innej możliwości, Andrzejku.
No tak.
Okay, so I'm sorry, just I need like, I'm sorry, just I will give you for a moment the information just.
If you can minimize the screen on the front of your Zoom.
Yeah, but this is just a matter of this that we don't have actually the right now signal in the camera, so that's why I will give you for the moment the host back.
Okay. No problem. We will wait little.
Problem. This is short technical problem. I will be ready in next 1-2 minutes. I'm sorry for the delay. Okay.
Okay.
Just doing this. Okay.
Hi, hello.
Audio. Okay, do you hear me right now?
Yes, it's very clear.
Okay, so
I turn for you the hosting. 1 minute.
yes, okay. And then I need just to have this one. Okay, so we'll have access. Now we can change it here to see the PGM and V. No, we don't have the signal here. So, okay, in general, we will change it to number 2. Where is our presentation? Yes. Okay. So, you hear me very well right now? Super. I'm happy. Okay, now I will just change to my presentation. Yes, so I will try to share my screen. Now I see everything, see it perfectly. Sure, okay. So, this is one story. Okay, let's wait and see if we are able just to deliver the quality information what we wanted. In general, welcome to everybody. Sorry for a short delay from my side, but it was related actually to the technical issues. This is my dream, just to deliver the high quality lectures always. So we were testing some new solutions as well for live streaming, but I didn't take under consideration one of the small things which I had to change immediately when we started. So this is just in normal way. I am in most of the cases the host of the Zoom, so and designing all the connections. In general, my preference for today is just to share with you information about dental photography, how important it is in my life and how important it is in general for any dental professional. In the past, because I'm taking photographs in dental field more than 20 years, and at the beginning, of course, we were just more with the solutions related to options like analog camera, slides, presentations with completely different setups. And now we are growing in completely different environment. Now, I live normally in Poland. This is north part, Gdansk, beautiful city. And in general, I have the practice here and I run it together with my team. And we have clinic with 8 dental chairs. We have own laboratory and as well printing centers, lecture room. So everything is set up not only for creating beautiful treatments and documentation for the patient, but as well everything is just focused on the high class treatment with perfect documentation. Because nowadays, in my opinion, but it's not only my opinion, without dental photography, you cannot actually reach a high level of communication, especially not only in between the professionals, but as well with people from or your colleagues, your friends, team members, but what is the most important, with your patients. This is the setup, one of the setups in one of my rooms, where you see the setup for photography, which is like a studio. So more or less, this is a system which is related to the rail system, where you see studio flashes connected with the soft boxes. And this type of solution I prefer, especially when we want to have a lot of light with powerful flashes, where you are limited with the access, which is in my case, especially during the surgeries, because I have to take under consideration safety of the treatment, but as well information for the patient, just to keep everything in a distance and deliver the light in the most, let's say, challenging situations where we have some surgeries. Over the years, I gave a lot of courses about dental photography, and a couple years ago, we created the platform, which is Dental Photomaster. And this is the platform where you can learn actually a lot about dental photography, starting from the equipment which you should choose, finishing with the lessons, classes, but as well the blog where we deliver articles about news and as well new things which are related to dental photography. This is the platform only dedicated and focused on dental photography. In the private life, I am together with my wife as pro videographers and photographers, cooperating with different agencies. And diving especially is our big passion, and we love it. And this is the one of the shots where we were filming underwater manta rays, and we are doing this type of materials as one of the crews for underwater documentation, for instance, for Discovery Channel. So we have these options, and in the private life where we can approach completely different environment, different animals, and it gives us a little bit of let's say freedom from the one side, but unusual experiences which affect your mood and as well what you are doing in your life. So if you like photography or you don't like photography at the moment, maybe you should start with maybe easy tasks like maybe taking some pictures of flowers, or just to practice, and then start doing this with more confidence in dental field. When we talk about dental photography, I have to admit that I need to highlight, I am talking and teaching about medical documentation. This is not a type of documentation or type of photography where sometimes I see during the courses where the highest attraction is with this kind of artistic photographs. I call it dental porn photography, and because these are certain reasons. Of course, you can highlight, you can make the pictures with the fruits, nice portraits with different moods, but this is like an addition. I'm talking about documentation, something what will help you in a daily work, in your daily practice. Because when we talk about dental photography, we have dental portfolio, case documentation, treatment planning, color and shade analysis, shape and texture, surgical documentation. This is just a few of them, but main, in my opinion, which are in main interest of us, it's dental professionals, dental technicians, as well assistants, hygienists. And we need to understand that the two biggest groups which are involved in dental photo documentations are clinics, doctors, clinicians, and dental technicians. And when we compare the number of or the type of photography in between these two groups, the main difference is that in the clinic we take some additional surgical documentation and some procedures documentation related to the treatment. But in the laboratories, especially recent years, we see that technicians take as well dental portfolio, so the set of the full documentation. They want to document their beautiful cases, and actually on the Facebook you can see amazing photos of our colleagues who are taking beautiful pictures, documenting them during the production. They also are involved in the treatment planning. They are involved in color and shade analysis. They take as well pictures of shape and texture just to analyze especially what they do with the teeth, with the layering, but as well they are specialized, in my opinion, in product photography. So just to take beautiful documentation of the shots of the layering ceramics, it needs some understanding of product photography as well. So what kind of tools you should use and how it should be done. When we talk about dental portfolio, first of all, we need to understand that we have to take not only the teeth as a setup, but as well full documentation of shots of the face. Actually, some clinicians will ask me, do I really need all these pictures? Actually, not at the moment if you are not ready to read the information from these pictures. Sometimes enough will be just to take front shots and only right profile, just for the simple analysis or just planning, especially in the 3D environment. But for the clinicians, sometimes it makes sense just to make not only the face, just to take some close-ups of the teeth. What for are specific close-ups or positions? Of course, it comes from the analysis of the cases and planning. So when you need the lips in the contact, when you need teeth apart, when you need a full smile, just to analyze the position of the canines, teeth, asymmetry, symmetries. So this is everything related to the planning, but as well for the communication. For doctors who are involved in the treatment planning, they want to have as well correct documentation of the oral cavity. So we need the close-ups of the upper front teeth, and not only just MIP position. We need as well the close-ups. It would be nice just to have some information about transparency, translucency of the enamel, if it is the case for, let's say, restoring with veneers. But as well, we need to have the shots in the mirrors, occlusal mirrors and buccal mirrors, just to analyze the contacts, the guidance, the class type of the patient. So this is more for the clinical. In 2016, I wrote a book which is like a display, which is with the information about how to take specific pictures. And we tried to represent in this book, in this display, this kind of information, what kind of setups you need and what kind of communication and what for you need specific pictures. So if you have someone in the team where you refer what kind of pictures they should take, this may be a helpful tool just to have something on the desk during they are in the process of learning how to take these pictures. During this lecture, I will give you some information, some hints and tips, but actually we are in the process because actually in half an hour, 1 hour, it's very hard and difficult just to give you all the information. So maybe in the future later, we will create like a course which will be like a summary, but very, very intensive with the demonstration, how I do such a things and what you can actually what you should look for. These are my intraoral photography settings. So I use my camera in the manual mode, and aperture which you set in your camera should be in between f22 and 32 for intraoral shots. Shutter speed is from 1/125 to 1/200 will be just the preference, and ISO is around 200. For portraits, the only difference in my setup is aperture. So I'm coming back with the slides. So with the camera settings for intraoral photographs, you have the highest aperture number with letter F in front. For portraits, you change only aperture to the f11. This aperture will allow you to take beautiful shots with the sharp face, starting from the nose, finishing to the ears. Case documentation is the part of your job, actually. I think about clinicians, but as well dental technicians. Of course, in the clinic, we document the process, and based on documentation which you take, you can make like a follow-up of the treatment. It doesn't matter if it is within 1 hour or it is within 1 year or few years. But the most important is just to control in the photography the quality of your photographs, that we will have correct exposure, correct color, and as well framing at the end. When you look at this composition of the pictures with simple composite, which was replaced or placed, you see almost the same shots, almost the same framing. But what is very important, you have perfect color and control about how they are focused and oriented. And it doesn't matter for me if it will be classical treatment, if it will be general dentistry, it's endos protocols, some prosto protocol or surgeries. I expect from documentation that everything will be in the same color. First of all, So we are controlling a white balance, but as well we are controlling exposures, that they are not too dark or not too bright, and as well cropping. All of this stuff, all of these things we are doing in so-called post-production. So when we download pictures into the camera, into the computer, then in the dedicated softwares, we prepare the exposure, we are checking white balance, and we are correcting everything that all the pictures are exactly with the same color. So we can do it with the surgeries, which is very, very challenging and very demanding, but exposure and post-production, this is one story, but delivering correct amount of light and the quality of light is crucial in such a documentation. I will give you an example of the cases which we document. This is from the short sequence of the pictures where you can see initial setup, problem with the number 2 on the left side, which had to be extracted. So you see a very clean and clear demonstration of the information about what we are doing, where we want to document specific steps. So in surgery, it is very critical that we take pictures without too much blood or fingers or anything which actually distract the attention. So for my team, it's very important just to keep the bleeding away, just to use the correctly suction, but in the same moment use, for instance, contrasters and mirrors just to document such pictures. The same or easier, much easier, is just to take the pictures with the prosto. And with these steps, of course, we have to control as well light. And in dental photography, especially, it's critical when we send the information with the color that we set up correctly our light. Because the worst light or worst type of flash which you can use for the color transfer is the ring flash. If you are using ring flash at the moment, is the worst type of photographs, because you can do nothing with this information, because the reflection of the light is very, very big, and you have really problems just to read the information about the color from the tooth structure. So you can use as well for reading the color or checking the color, especially dental technicians, they like it if they have such a possibility. They come with the shade guide, and in our clinic we have this type of tools where they emit the light, which is 5,500 kelvins, and it gives us this white light just for safe reading with the, let's say, natural or objective light. For color measurements in our clinic, we work with the digital workflow. We have our own laboratory, and in the team I have 7 dental technicians at the moment, where we have international team. I have Italian dental technicians in my team. And one of the best from young generation ceramist, Nicola Squicciarini. And so this is the type of work what we do as well to transfer the information. We are using so-called ELAP protocol. So we take the pictures with polarized, cross-polarized photography, and using the software from ELAP from Sasha Hein, we are measuring and correcting, or just trying just to have the correct mixture of the dentin with colors, just to have the foundation for building ceramic, building the crown. Of course, everything is related to the type of the solutions which we want to deliver, but the goal at the end is just to make a digital try-in, which dental technician is doing during the process of building the crown, and it helps a lot at the end just to finish the case and deliver it with perfect results. Of course, the color is one story, and the fitting is another story. Texture, this is high class at the end of the skills. What is very important when we take the photographs, especially on the certain level, we want to get higher magnifications, but these are one of the most challenging photographs. And this is with the ratio magnification 5:1. So you need for this the special setups with special lenses. And this is not the standard type of picture, but as you see from this shot, you can get amazing results showing the quality of the soft tissue before the crown is in place. So based on such approach, we are able just to have really very good results and documented results where at the end we can compare before and after and show it to the patient, show it to our team, but as well document it and analyze to learn ourselves. Depending on the light quality and the light direction, we are able to read from the pictures information about the texture, and this is very critical, how we position this light. So whatever photography you are doing, at the end, it is just a matter of understanding the light, how the light works and how the light creates this beautiful information about the texture and shape. Information related to the dental treatment and the dental planning especially are more related to this medical type of documentation where we have shots of the face, close-ups and intraoral shots. But there are some rules which we have to follow, and these rules are that face has to be oriented always in a way that we will have the so-called gnatostatic orientation, which means that we align like a corner of the eye with the superior helical attachment of the ear, and it should stay in the same plane. So it is like it was proposed and actually offered for the first time according to my knowledge by Panos Bazos, and this is excellent clinician focused on orthodontics at the moment, but he made his analysis and this is very, very helpful. I will talk more about these gnatostatic positions and orientation of the face during this course, which is planned in November. I think we have like 3 hours in this next meeting, and then I will go deep in the details, what kind of orientation is it and how to control it and communicate it with the patient. Nevertheless, photo equipment for shots of the face could be used exactly the same as you use for intraoral photography. So it means it's the same camera body, the same lens, which is macro lens, and you can use even flash. However, the power which comes from the flash, which is ring flash, can be too weak just to deliver a good information about the face. That's why in most of the cases, colleagues, they are taking shots with the external light, like speed light flash, which gives better control about the light. This type of portrait which you see was created with the softbox. So it was created actually with one softbox, which was at the top of the patient or in the front, but upper, and with some reflector, which was under the chin of the patient. And these are the shots which we are taking in a series. That's why you can see very nicely the position, which is oriented. You should see both ears during such pictures, and the chin shouldn't be raised up. You have to keep the face looking straight into the lens without raising the chin down, up or down, because then we will have distortion of the face. Distortion of the face is related as well to the type of the lens which you use, and that's why we recommend very strong that you should use the lenses which are actually macro lenses as well, used for dental intraoral photography, which are around 85-100 millimeters, and these are the best one because it will give you the lowest distortion related to these photographs. So once again, just to repeat, these are my camera settings for portrait photography. Portrait photography we are using in this clinical approach as well, and not only just to take the face, but as well to transfer for instance, information from the face bow in a quick way, in a simple way, to the articulator. And this type of things, I have to give a credit to André Cardoso from Portugal, and Pedro Rodriguez, and from them I learned this method of transfer. So it helped me especially in the past, just to transfer in the manual way or analog way the information from the pictures as well to this information about positioning on the planes. Digital smile design, a lot of people heard about it, but less people are using it. We are working with digital smile design every case, because it's not only to motivate the patient, but to analyze what we are doing. And actually you take as well shots of the face, but we take as well shot of the so-called 12 o'clock, which is number 5 in this screen. And if you know how to later on use these pictures, or you are a clinician, you send it to a referred laboratory who knows how to use these pictures, just to orient in the correct way in the first moment, just aesthetic design, but as well when you combine it with the 3D modules or 3D softwares, like as well Nemotech or Exocad, you can combine all this information as well, or transfer it into 3D models where you can print the mock-up and work as well with the more information in between laboratory and clinicians. This is the type of communication which we can read from these pictures and transfer it to orthodontist, for instance. So this gives us as well very, very clear information where to move the teeth and how to communicate to the patient, and how to communicate especially to orthodontists what we expect, because sending patient without information, this is just lack of information. And then we cannot expect that this type of treatment will go very good. Intraoral photographs, of course, we have 2 types of flashes which we can use. This is ring flash and dual flash as a standard mode. The same settings, f32, 22, depends on your camera and lens. Actually, this is related to the lens construction. What is the maximum aperture which you can close or open? But the goal is just to have beautiful close-ups, but with, once again, correct orientation. Correct orientation means like a protocol that every case is done in the same way. It doesn't matter it is just now or in 5 years or in the past 10 years ago. The goal is that we have the same type of the pictures which we can compare. Of course, you can take, besides of this one, anything what you want. But some basics, some foundations should be done in a correct way. Color and shade of the modern approach, I just showed you already with this type of pictures, but this allows me, especially with the digital workflow, to make this type of situation cases without immediately before the surgery happens. Here patient will lose central incisor number 21. And the goal was just to deliver immediately after surgery a perfect crown, which will be in the same color and in the same shape. So based on the information which we sent to the laboratory with cross-polarized photography, Nico was able to prepare such a crown. So then we could start the surgery. We do, I am an implantologist and I graduated in 1993. But I started with implantology in 1996. So I have more than 20, almost 25 years of the experience, but from a couple of years, we are right now only doing 100% cases with guided surgery. So it doesn't matter if it's single tooth or full arch with all-on-4 or all-on-6. So the foundation of such a treatment is, of course, very precise positioning of the implant, because then we can deliver immediately ready to go crown. So if you are very precise in implantation, then you can deliver such a crown. This is the crown which was delivered immediately after. The rule is that we have to have very good photographs. So this is the shot after a placement, just for checking how it is in the mouth. And these are the shots showing before and after, the same day, 1 hour later, different crowns. Implant and 2 different crowns. This is the case after healing. So we have quite nice stable position of the soft tissue and the crown, which looks very good, and patient was very happy. Shape and texture, I said that this is just a matter of color. This is just a matter of the direction of the light. So you have to know how to control the light in the volume of the light, quality of the light, but as well where you place, how you position this light. So it gives you the information or chance just to take some shots from the sides, from different angles, just to highlight this type of, let's say, beauty photography, just to show some texture of the teeth. And depending on the direction and the power of the light, this needs some practicing, but it's a lot of fun. And especially when you see sometimes patients with beautiful teeth, you just add additional few minutes more in your appointment just to take these kind of shots where patients are also involved and happy. So depending on the quality and the volume of the light, you can just register amazing things on the surface of the teeth. And this type of texture helps a lot in the communication with dental technicians, how to really go with these pictures. Product photography is more related to the lab work, and but because I work in both in the clinic, in the lab as well, so we are using our facility and the materials and tools which we have just to document it in the perfect way, just to deliver enough amount of light, just to deliver as well this type of pictures which are very clear to understand and very clear to show, because in such a cases you can just show the specific features of the crown, translucency, transparency, shape of the tooth. And product photography in general, in my opinion, is everything what you take outside of the mouth, which needs a special setup like the special tables, or you are doing it even on the mirrors or on the freehand situations. So you can take it with the black background, with white background, and you can make it with different light positioning just to have illumination of the structure, what you can do and how you can present it. Because sometimes if you are the lab owner, you would like to present the quality of the work you deliver. And actually, what is your communication? The only communication where you can convince other doctors just to come and take the chance, give us a chance to deliver this quality. It's just to document and show your cases. So of course you should get as well, if it's possible, some pictures in the mouth from the doctors. But what you are delivering is actually this type of pictures you can take easily. And then you can practice. So I will show it as well how to take such a pictures. Surgical documentation is the most challenging for the doctors, because we have not only patient, not only camera setup assistants, but as well a situation where we cannot make it with endless time. We have limited time for the surgery and anesthesia. So depending on the type of the surgeries, we are taking shots which will document specific procedure, which will document specific type of the protocols or tools which are used, everything just to show how this specific protocol was taken or given. In my case, I am speaker, and I write books and articles. So the quality of documentation for me, especially from the surgery, is critical. So, but in case you are not lecturing, documentation from the surgeries helps a lot in learning process. I learned a lot from my mistakes, which I did during surgeries, during analysis of the pictures, because our brain will always tell you after a while that we did perfect everything, but actually it's not always the case. So we need to understand where is the difference and from where it comes. Recipe for the great photo. This is something which I learned a lot years ago because in 90s I was as well learning in the New York Institute of Photography. It was for me the foundation of photography skills which I have on the pro level. And one of my teachers told me that if you want to really get a good shot, always think about subject. What is the subject of your photograph? How to focus attention. So it means how to direct your imagination, your focus to the specific part or zone of the picture, and simplify, just to make it simple. And this is, for instance, great example of the veneer, prepless veneer on the central tooth. So if I would just give you this picture without commenting anything, asking what is the title of this picture, you could say easily central incisor or veneer, prepless veneer. So it is just one of the options. Recommendations about the equipment is very hard, of course, to tell, especially when we talk about camera types. So I will just highlight it, just mention it at the moment, because we can go with smartphones, we can go with mirrorless cameras and DSLR cameras. Of course, different solutions, different equipment setup, but at the end, it's important for us what kind of quality we can deliver. So depending on the quality, your knowledge, you will prefer simple solution like smartphone, but from the other side, you would like to have more advanced with mirrorless or DSLR cameras. Macro lenses, this is also the wide selection of this type of tools. And in my opinion, one which you have to remember is, of course, the focal length, just to have to avoid these problems with distortion of the face, but as well the minimum focusing distance. So how close you can go to the subject and still have some space for patient to breathe, to avoid fogging of the lens, but as well to have the possibility to access the light or given access to the light. So we need to really consider all of these steps and before we are selecting. Flashes, of course, in the foundation we talk about ring flash. The more advanced users will look for the dual flash. The people who are already masters in ring flash and dual flash, they will look for even pro solution which are based with studio flashes, with the studio light setup. Depending on the type of the light which you will use, you will have completely different results in your photographs, and this is critical. So for your information, this is the example. On the left side on the screen, you see the ring flash picture, and on the right side of the screen, dual flash picture. The same patient, the same time of the appointment, different light source, different light setup. Ring flash, central light, you have huge reflection in the front of the teeth, no information about the color. Dual flash, light is on the sides, that's why buccal corridors are dark, but you have a lot of information about the color in the central incisor. Accessories, different types. Actually, the two which I can recommend, always you will need them at the moment. So this is self-retracting retractor, the most common which we are using, just to have the front shots and easy access, and mirrors. Mirrors for occlusal shots, I use the biggest one available, and sometimes we trim this kind of retractors just to have better access, and then take very nice pictures of the occlusal shots, upper and lower jaw as well. If you would like to get more reference about the equipment, this is there is section which is free of charge. You don't need to pay anything. You need to just register on the Dental Photomaster, and you have access to some of the lessons which are for free. But as well, you have access to the equipment section, and as well you have access to the blog. So you will find a lot of references related to the equipment as well. So from my side, I would like just to finish in this moment, and this is what I would like just to say, that this is the moment where I have to find my Okay. I need to find right now the access. Yes, I have it back. More. So I will try to give back the host, and we will have and then the chance to talk and hear each other. Do you hear me?
Yes, fine. Yes.
Okay. So I give you back the host. So I hope it was worth watching, and for people who are interested in more details, we are ready to go with more advanced information and very practical information.
Yes. Okay. The course will be on 9th of November. We invite all the interesting about to know exactly and in practical way the steps and the protocols how to make professional photos to join us. We looking also for more information for Mr. Dr. Christoph Chmielewski, and thank you very much for sharing this information with us in a dental online conference. Uh, Thank you very much. And if there is any
You're
questions,
welcome.
also you can send on the comments on the YouTube and
Okay. So is there chat
yes,
visible?
there is a chat.
If there will be something,
Yes,
so
only some thanks for this information and wish we can have some questions. Only some
mhm.
likes for this interesting
Super.
information. Thank you
Thank
very
you.
much.
Thank you.
Thank you. Thank you very much.
You're welcome. Thank
Thank
you.
you.
Thank you. Bye bye.
See you. Thank you. See you. Bye bye.
Bye.
Bye, Doctor.
Bye.
في عنا حوالي 10 دقائق لحتى نبدأ المحاضرة القادمة. We have about 10 minutes to start the next meeting, which is about 3D printer of zirconia with speaker Sandra about Lisso's LCM technology. We invite you also for the courses will be start in 1st of November. The first will be for technique of natural bleach veneers with Master Dental Technician Nondas Fletcher Ployce. The second is in 2nd of November with Dr. Pablo Ishari about protocols of analyzing and diagnostic clear aligner and treatment plan. The third one about PRP, about Dr. Rustilli Carpini. It will be in 3rd of November. The fourth one, it will be in 5th of November with Gianfranco Bartolini about how to aesthetic implant position step by step. The last one, it will be about dental photography with Mr. Christoph Czerwowski about steps and procedure how to calibrate your cameras to capture nice photos for dental application. You can participate by visiting and joining the Dental Online Conference website. You can find courses and register for the interesting courses you like to join. We have about 7 or 8 minutes to start with our next lecture. You can visit the courses and you can register for the interesting courses about ceramic white aesthetic bleach veneer from the link register, and you can fill your information and we can connect with you and give you the steps how to start this training course one another. We have also about clear aligner, which is very important, new technology to make orthodontic aligners. About treatment plan, we have also about facial aesthetics for dentistry. We have about implant course. We have also for Dr. Mauro Frediani guided aesthetics treatment application, which is very interesting to get digital smile design, and also dental photography. Also. Welcome everybody. We invite you to join us in dental online conference, free conference, and also we invite you for the next conference will be held in 15th of January. We also invite you for the courses that we organize in 1st of November. We have Master Dental Technician Nondas Vlachopolich about technique of natural bleach veneers, how to give the vitality in the anterior veneers with the ceramic application. The second course we invite you is about how to design clear aligner with Dr. Pablo Echari, hundred of articles and books, and he is the master who can simplify the concept and complex of orthodontic treatment plan, and he is the guide of this technology and the chairman of Westlaw in the invisible orthodontic. Also, we invite you for PRP, the design of the art of Dr. Rosdelli Carpini. She is artist in PRP, dermal fillers, and PDO. Yeah, we invite you on the course of aesthetic analysis with Dr. Marwa Fardiani on 6th of November, which is the author of the dental dentistry. In this book is the guide for digital smile design. Also, we invite you for dental photography course, which in protocols how to make the beautiful photos. On invite you on 5th of November about Gianfranco how to aesthetic implant positioning practical course. He will work by his hand case. He will walk and step by step make every treatment for the implant cases. all ceramists interesting to make the nice, beautiful veneers, also invited for non-das Warhoves about bleached veneers. Now our guest coming. Hi.
Hello.
Hi, hello. Hello, how are you? Hi, Sandra. Nice to meet you. We introduce you Sandra Ballini about, yes, the expert of 3D LCM ceramic 3D printer from company, the pioneer on the 3D printer of ceramic lithos from Austria, Vienna. We are going to study and learn how this technology is changing the future of the dental industry in the aesthetic and restoration and for the bone production. I will give you now the host to share your screen. 1 minute. Thank you.
Okay, perfect. I will share my screen. Can you see my screen, my presentation?
It's clear. Perfect.
Perfect. Okay. So thank you for the nice introduction. My name is Sandra Balnik. I am at Lithos in Vienna, and I work here as a business developer in the medical department. And today I will tell you something about the LCM technology in general, as well as the dental and medical applications and our newest possibilities and the newest things that you can do with our technology. Let's start with a short overview. Lithos is the world's market and innovation leader of 3D printing of ceramics. So from Lithos, you can get the whole solution for 3D printing. We offer the 3D printers as well as the materials, the software behind it. And it's also possible to let's do some material developments together. If there's some material you want to print with and which is not from us or which is not in our product field, that we can develop it together. So it's really important for us that we have a good cooperation with our customers and that we are always there to develop everything together with them and help them if they need it. We are more than 70 employees right now. We have stay in 2 locations. One is the headquarters in Austria and Vienna, and the second one is in the USA in New York City. And we sold more than 70 machines worldwide until now. And 1/4 of our customers bought more than 1 machine from us. So that's the thing that we're very proud of, that that our customers are so happy to work with us together that they want to invest in more machines and in our systems. So this is in short overview of our reference customers. As you can see here, we have many customers from the industry, but this is just a few. There are just a few of it. For example, Kalis Martin or Cerix or Otto Baltic Implants, so many medical companies, as well as some competence centers for R&D institutes, so like the Technical University of Berlin, Fraunhofer IKTS, or the University of Zurich, for example. There are many cooperations we have with such centers like this. Now, just an overview, so go deeper in the LCM technology and how it works. LCM, the word, means lithography-based ceramic manufacturing. And I will show you how it works, how the process works. So this is a short overview from our process chain. As you can see, it starts everything within CAD design. So you have a file or a geometry you want to print, and you put it with our software on the building platform at your computer, and then you can print it up. and I will show you later and how to build the part up with our technologies. If the part is built up after the print run, you have to debind and sinter it. So you got to get a green body after the printing process, and afterwards you can debind it. So the part will debind and are then sintered, and then you have the final product. This is the principle of our technology, so how it works with the principle of photopolymerization. So as you can see here, there is a 3D CAD model, and our software sliced this model into the images. And then we have here in our projection system, we have here a blue LED, and here is the projection system, and the blue LED shines at it, and there are mirrors that I can show you later. There are mirrors on it, and the mirrors project the layer you want to print on the bottom of our vat. So the material, the slurry is in the vat, and from the bottom there will be the blue light, and because of the blue light the material gets hard, but only there where the light comes. So you can see here the white one is the layer, and that's the area which gets hard, and that's the reason how you can print the ceramic and how it works to print it. You can see here how our projection system and our machine is built up. So I will start from the bottom here. You have here the LED, as I told you before, and this is the optical system. So there are many mirrors which project the layer you want to print on the bottom of our vat. And this number 2 is our vat, and from the top of the machine, the building platform comes down and dips into the vat. Then the projection system projects the layer on the bottom of the vat, the material gets hard, and then the building platform comes up again. And that's the process how the part is built up. So you can print it then layer per layer. So the projection system projects every layer per layer on the vat, on the bottom of the vat, and the building platform dips down. The material gets hard and stays at the building platform. It comes up, and the next layer will be projected. So that's the thing how it works. And now a bit deeper in the debinding and sinter process. So you can see here that we showed it with a geometry, and this geometry is actually our CEO. And you can see here that this is our green body. So this is the part, how it looks after it gets out of the printer. And you can see here in the graphic that you have, after the fabrication, you have the slurry, as I told you before, which is mixed from ceramic particles and photopolymers. The photopolymers are necessary that you can print a part and build it up with the blue light. So that's the reason why it works and how it works. And when you have these together, you can see that you need to debind it, that all the organic stuff and all the photopolymers are burned out. So you can see the part is a bit smaller after the debinding process. But it's also, you can also see that the yellow, there's many space between these yellow dots, so it's not that dense, the part. And that's the reason why you need the sintering process. So it gets sintered afterwards, and then you can see how big the shrinkage is between these parts. And then you have a full dense part only with ceramics, because the debinding process burns out the whole polymers and organics, and then you have only the ceramic left. And the shrinkage between the green body and the final result is between 25 and 30%. So there's a big shrinkage, but we know the shrinkage before, and that's the reason why we can print it and build it up, and the part is as big as we want it in the end. So here a short overview of our machines and printers. We started with the Serafab 7500, and last year in March, so 2019 March, we presented the Serafab 7500 Dental. In November 2019, we were at the Formnext fair and presented our newest system, so the Serafab S series. So this is the Serafab system series and the family of it. The difference between the machines is, between the older ones and the newer ones, is, for example, the speed. as well as how big you can print the layers. But the difference between the machines in general is most of the time the lateral resolution, as well as the number of pixels between these two types of machines and the building volume. The building volume is a big difference because the Serafab system S230 is, for example, the biggest one, and the Serafab system S25, the smallest one. Yes, so it depends on what you want to do. And you can see here that you can buy the new Serafab system machine in only one unit. So you have your machine with your docking station where you can operate the whole machine and start the print runs and something like that. And it's also possible to buy more units. So you have an module machines here, and all of these machines are controlled with this control station. So you have one point where we can start the print run for all 4 machines, and you can have one dock station where we can stop it for all of them. So this is really interesting for industrial standards and for the industry. And now a bit deeper in the ceramic materials in our portfolio, what we have. I just want to give you a short overview why ceramics in medical engineering, why it's important to have this and why we do it. Ceramic is bioinert and bioresorbable. So it's also possible to print with our printers bioresorbable materials such as tricalcium phosphate or hydroxyapatite. The ceramics is non-allergic, so there are no irritations or something like that. And you have no artifacts at the CT or MRI. It's also easy to sterilize and has a really high mechanical strength and no electrical conductivity. This is just a picture from our material portfolio. So as you can see here, as I told you, this is tricalcium phosphate, for example. The blue one is the hydroxyapatite. These two are the bone replacement material. It's also possible to print bioglass as well as alumina and glass ceramics, for example, silicon nitride, as well as zirconia. It's also a lithium disilicate. Sorry, I just changed it. And silicon nitride, of course, is also possible, which is a bit really interesting for the dental field, but I will tell you later a bit more about it. So this is a short overview of the medical materials. As I told you, our little bone materials, which are the bone replacement materials, as well as litacon, which is zirconia, and litonite, which is our silicon nitride. You can see here down there that we have also different tested the cytotoxicity, for example, or genotoxicity, and it depends on the material, of course, how strong and dense it is. So it's a bit different between them. It's also possible to print translucent and colored parts with our machines. So we also already printed 3 utericized, 4 utericized, and 5 utericized zirconia. So you can see here that there's a difference between the translucency, and it's also possible to add some colors during the print run. We also printed already the translucent alumina, which we are really proud of because this is not an easy thing, but it works very well, and we are on developing this field of material engineering. And as I told you before, it's also possible to print lithium disilicate as glass ceramics. So glass ceramic is really important for dental restorations because of the highest aesthetics points. Because as you can see in the picture there on the right side, that the zirconia crown is much more darker than the lithium disilicate one. So there's a big difference on the aesthetic point of view, as well as here you can see that there on this disc you can read the lithods, the written lithods logo under there, but not on the zirconia one. It's also good because it has a good and high mechanical strength, as well as the that is biocompatible, and it's easy to colorize. So with this high translucency, it's just a future thing for dental restorations. So now just a few points about bone replacement materials. So as I told you, tricalcium phosphate, it is the scaffold you can see here, the white one, hydroxyapatite, which is the blue one, and the blue cylinder down there, as well as blends of TCP and HA, and bioactive glass. This is also possible to print. So now I will tell you about medical applications we can print and solutions and success stories that we have. So it's possible to print really high resolutions with our printers. So you can see here a lattice cylinder made of alumina, and you have struts between 50 and 85 micrometers big, and openings between 100 and 120 micrometers big. So I think you can imagine now how small the part is big, but how small the struts and the openings are, and that it's not really easy to see it only with your eyes, because you just need an optical help or a microscope or something like that. But it's possible to do, which is really interesting also for the pharmaceutical point of view. Many pharmaceutical companies need some filters or something like that made of just a small lattice structure. Here are one of the best of both worlds. Here's one of our ideas that we had for the bone replacements. And you can see that there's a round there and zirconia cage, and inside there's a scaffold made of hydroxyapatite. And this idea is because bone is the second most frequently implanted issue in Europe after blood. And normally they use autologous bone for really big sized and critical sized bone defects to fix them, because you need the bone needs help or something between to grow in. And there are many bad things behind this autologic bone using, because there can be an infection, there can be some issues at the point where you take the bone, and there on the place where you put the bone as a new one in. And that's the reason why we thought we can check that and change that. And that's the thing how we created this idea, because you can see there's the zirconia cage around it, and you can give it in the jaw. So the zirconia cage gives the jaw the stability it needs when the bone can grow in without any issues or something like that. So inside you have the bone bioresorbable hydroxyapatite. So the bone grows in, and the bioresorbable material goes away during the bone growth in. So after a few years, the bioresorbable material is away, and you only have the zirconia cage left, which is a really important thing, because many people don't like to have big implants in their body which stay there. But the zirconia cage is here for the stability and to help the jaw to stay fixed. And now a short overview of our dental restoration. So it's possible to print crowns, bridges, or veneers, for example. We have the finest edges. So our edges are down to 70 micrometers small, so really small. And we have also the sharpest fissures. So they are really fine and specific, and which is a good thing, because you can print, I don't know, 20 of these fine specific crowns in one print run, and it's easier to produce than with the commercial techniques you use for this. You don't need to polish it afterwards. So if you have the print run is over, it's the surface is so good that it's not needed to polish it afterwards. And of course, it's possible to stain it afterwards or cement it as you like. So it's also the post-processing is possible in the same way like after commercial production things. As I said before, you can also print dental implants made of different materials. So it depends on what you want to do with. It's possible with zirconia, of course, alumina and silicon nitride, which is really interesting because of its anti-infective properties that they have. But many people don't like the gray color. That's the reason why the people are looking for a new solution, because the titanium, for example, is also gray. And sometimes you can see it under in the jaw. And that's the reason why the whiter materials are a bit more popular, I would say. You have a great design freedom, so it's possible to design your implant patient specific or as whatever you want to design it. And it's also highly productive to print these parts because they are so small that you can print nearly 50 or 60 in one print run. And it's also possible to print frets. So this is an M2 fret, for example, inside there. So and screw implant is with an inside fret. It's also no problem to produce with our technology. So here's just a short overview about our medical applications and success stories. So we have our medical Serofab systems in Europe, North and South America, as well as Australia. We have biocompatible materials, as I told you before. We have already customers who did CE certification for medical devices with class 3 with our materials, and with medical devices which are printed with our materials and with our printer, as well as FDA approved material devices in class 2A. There are already more than 10 surgeries performed in 2017. So we are already in the human body with our materials and with our implants that are printed. And of course, it's possible to print bioresorbable and permanent patient-specific implants, as well as other medical devices. So now the full digital workflow, how to get from your CAD design to your crown in the end. First of all, you need an intraoral scanner, for example, to scan the place what you want to fix, or where is the defect, what you want to where the implant has to be. And here's the process chain again, as I told you before, and you can see here down the pictures. So here's the scan, for example, from the crown. So here you want this crown to be changed, for example, or to exist there. Then you can print the crown. Afterwards, you remove the parts from the building platform, you clean it, and it gets debinded and sintered. Then it gets stained if you want to stain it, and then you have the final product afterwards. We have also new things to say. So we already have a new machine on the market this year, which is the multi-material 3D printing machine. And the first question you will get is why multi-material printing? So you can combine different properties and different materials, and therefore the properties of the materials in one component. So for example, transparent and opaque, you can also print 3D colored gradients, as you can see in the picture on the left there. This is a white tower with made of alumina with red stripes on it made of alumina, for example. You can also print thermally removable support structures combined with normal ceramic parts, as well as porous and dense parts, bioresorbable and bioinert parts, hard and ductile, or heat conductive and heat isolating, for example. And you can see here down on the right side how the different things what you can print from the different materials. So the gray and the yellow one, for example, are different materials, or here the dots and the yellow field, or the color gradients. This is also a thing which is possible. And yes, so the dots will show you the thermally removable structures. So the photopolymers will be away after the debinding and sinter process. Our new multi-material printer is called the Serofab Multi 2M30. You can, inside of the printer, you have two beds. You can effectively clean the material changes, and it's better to print with two materials in this way. And it's also a really interesting point that you don't need, with all our machines as well as in this one, not that much material to print with, so as little as necessary, because it's really important for us that our customers can develop their own materials, that our customers can develop new geometries, or in this case, how different materials work together. So you can put together the ceramic and ceramic, of course, you can put together ceramic and metal as well as ceramic and photopolymers. These are some samples that we printed already with our newest multi-material machine. So you can see here the ring on the left side, which is made of alumina. So the white ring within color gradient, as you can see here. In the middle, the plate with the Lithos logo on it. This is also a printed material, a printed part with our multi-material machine, and the letters are printed made of zirconia, and the whiter field around it is made of alumina, for example. We also have these yellow discs, so you can see that around you have two circles, and the outer circle is made of alumina, the higher one made of ZTA, so zirconia, tungsten, alumina, and the inner one is made of alumina again. So you can also make designs like this, for example. And of course, biomedical applications. So you can print also the whole cage that I showed you before in one print run. So the cage here around it is zirconia, and the lattice structure inside is made of hydroxyapatite, for example. And as you can see, the ring here is as fired, so that means it's sintered already. This field with the Lithos logo on it is also as fired, as well as the ZTA and alumina part, and the green implant there down there is a green body, so it was fresh out of the printer, I would say. Yeah, so what is possible for the dental field with our multi-material machine? So we have a 3D color gradient. So you can see here on the picture that it's possible to print colors. So we got these fresh out of the sintering furnace. So we didn't stain it or something like that. You can see that there's a big stripe. So the gradient is from yellow to white here. And there you can see how the gradient works. So it goes white and will be a bit darker to the down there. We just wanted to show these big stripes in between because we just want to show the big difference between the colors here. The right crown, you can see that there is just one gradient on the whole ground, and it's a bit darker on the more jaw side, and on the top of the crown, it's a bit more white one. Yeah, so thank you for your attention, and I hope you get a short overview of our work and what we can do. And yeah, I hope you liked it, and I'm open for your questions. Yeah, so thank you for your attention, and I hope you get a short overview of our
Hi, hello. Thank you very much for your information you shared with us. It's very interesting and attractive information. We have some questions. Three iteria zirconia. What is the flexure strength you have with this material?
We have a 4-point bending strength, about 930 megapascal.
Super.
Material.
Yeah, super. And you are starting also a new material like lithium disilicate glass ceramic. You have this new material. So also you can print the glass like transparent feldspathic or natural glass.
Bioglass, for example, is possible to print, and the other materials for lithium disilicate, as you said before, it's also possible. So we tried a few things out, but it's the development behind it that when we are customers who want to do it, we can do it.
Super. The small parts like veneers, how normally we need, for example, if we have thickness of 0.5 millimeters, the sintering cycle, how it longs, if it's small parts like half a millimeters.
Depends on the material. So, for example, alumina is, if especially in small part like this, debinded and sintered really fast. I would say in 12 hours, one day. And it depends on how big the part is and how the wall thickness is. So how it, let's say the material is, it's a point where it's really important on this thing, as well as how big the part is and how big the wall thickness is.
Very interesting. The finest sintering is normal, like the zirconia from milling machine.
Mhm.
The finest sintering is 1,400, 1,500, same.
Yes. Yes.
For this biocompatible material for bond, hydroxyapatite and tricalcium phosphate, also there is some surgery you do in this material, and it is in the body, as you mentioned now. This is
Yeah.
so
Since
you already,
2017, yeah.
yeah, so you have already some test and everything to get
Yes,
it
yeah.
in the body.
We have different papers
Very
about these materials as well as the surgeries, but I can't tell you more about the surgeries because are for commercial things with our customers.
okay. Thank you very much. I think that this is the most questions we received today, and we will invite you again in 15 of January for the next event about the new development you have.
Thank you.
Thank you very much. Have a nice
Thank
day.
you. You
Thank
too.